Okay, today we're going to be looking at hyperbolas, which are sort of similar to your ellipses. The graphing is very similar, so that's great. So your specific definition or technical definition, is the set of points in a plane, the difference of whose distances from two fixed points called the foci is constant. So from your point, this distance to the other foci and this, if I take that difference, so subtract those two, then that would be the same as if I take these two distances and subtract them, and if I were to take these two distances and subtract them, all of those differences would be the same. Okay. We also have something called the transverse axis. The transverse axis is the segment that joins the vertices. So here's your vertex and here's your vertex. So this line segment right here is what your transverse axis is. So we did that in red. Okay. So your standard form of the hyperbola looks very similar to your ellipse. The major difference is that, first of all, there's a minus sign in the middle as opposed to a plus. And then notice that the a squared is always on the left-hand side. Okay. So we don't have that distinction that we had yesterday where a squared is always bigger than b squared. This one, it doesn't matter if a squared is bigger than b squared. Okay. Also notice that in your c squared equation, rather than being minus in the middle, it's a plus. So the way that I remember that is if there's a minus in the standard equation, it has a plus in the c squared equation. If it has a plus in the standard equation, then it has a minus in the c squared equation. Okay, but notice that your center is exactly the same. It's hk. Okay, a is the distance from the center to the vertices, so it's that same distance. Here's your a value right here. Your c value is from the center to the foci, so that's your same thing where this is your foci right here. Or you can look at these pictures down here. This is your a. And this is your B. Oh, on your bottom picture they switched your B squared and your A squared. In your book you don't switch it. I just pulled that off the internet and didn't see that till just now, so I apologize about that. Okay, so you have two ways that it can open. That was not true what I was going to say. I can open it towards the x-axis or I can open it towards the y-axis. Notice the other difference that you have. Since there's a minus sign, it matters which one's positive. Typically they put it first, whatever's positive, but that's not always true. But that's just something typical that happens. Okay, so if it opens, if your x is positive or if your x is first, that opens up towards the x-axis. If your y is positive, or if your y is first, it opens up towards the y-axis. So whichever one is positive is the axis that it opens up towards. Okay, so graphing is very much similar to what we did yesterday. You have this information here. Okay, then it talks about how to find the asymptotes. I'll go over that when we're doing the actual problem. So let's start off by having one that is graphed at 0, 0. So notice our center here is 0, 0, just like we had the other day with our ellipsis. Okay, our a squared is 16 and our b squared is 36. So on hyperbolas, it doesn't matter which one is a squared and b squared. Well, it doesn't matter which one is bigger for the a squared. So your a squared is just always on the left. Okay, so that means that my a is 4 and your b is 6. Okay. So I start graphing in the same way. So I start at 0, 0. The x is underneath, or the 16 is underneath the x. So I go left and right by 4. 1, 2, 3, 4. 1, 2, 3, 4. Then your y value is, or sorry, your 36 is underneath your y value. So I go up and down 6. So 1, 2, 3, 4, 5, 6. Did I count right? 4, 5, 6. Yeah. 1, 2, 3, 4, 5, 6. Count today, apparently, my lines. Okay, so at this point, then we would have graphed an ellipse, right? But today, what we're going to do is we're going to create a box, or a rectangle, if you will. Okay, so the rectangle that we're going to create is where these 4 points are the center of, or the midpoint of each side. So the box that I'm going to create, and I'm going to just create it as a dotted line. I'm going to do it in highlighter so you can see it better. Okay, so you create this box similar to how you created the ellipse, right? But now it's just a box form instead of an elliptical shape. Okay, so what happens when you're graphing is that you need to create these asymptotes. So these asymptotes happen from the center through the diagonals or through the corners of the rectangle that you just created. So my asymptotes look like that. Okay. I'll tell you in a minute how we're going to get the equation of those. So as far as our graphing goes now, all I'm going to do to graph it is I'm going to take the vertices, which are with whichever one is positive. So since x is positive, my vertices are the x direction. Or you can think since the x is positive, it's going to be opening up towards the x-axis. So I'm going to create it like this. And then I just create the shape that follows the asymptotes. Like that. Okay. Now, your foci is found in a similar manner, but it's c squared equals a squared plus b squared. So if there's a minus in the equation, there's a plus here. So a c squared is 16 plus 36. So I get 52. Okay. So it's 2 root 13. I was having problems thinking of what was divisible by 52 and if it would break down enough to pull something out. So you get 2 root 13 is your C value. So if you do 2 root 13 in your calculator, not 139, just 13, you get 7.211. So your foci are still along, or not still along, it's along where you're opening up. So your foci are going to be inside this, it's kind of a parabola shape that's sideways. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7.2. So here's one of my foci, or foci. Oh, just joking, that was 4, 5, 6, 7.2. So there's your other foci. So notice it's on the inside of each parabola half. That's why it's called hyperbola, because it's similar to a parabola. Anyways, so that's your foci. Now to find the equation of the asymptotes, notice that we start here at 0, 0, and this line is your B value over your A value, right? This was B, this was A. So you're going to have y equals plus or minus B over A x for your equation of the line. So I have y equals, my B value is 6, so plus or minus 6 over your A value, which is 4x. And then I reduce that to 3/2 x. Notice I keep the plus or minus because I have one that's a negative slope and one that's a positive slope. Okay. On our next one, it's not in standard form, so I have to divide everything by 64. So 16 divided by 64 is 1/4, so I have y squared over 4 equals 4 over 64 is 16, so not equals, minus x squared over 16 equals 1. Okay. So your center is at 0, 0. Then your a squared is 4, and your b squared is 16. Notice that the a is always on the left-hand side, regardless that we've switched the y to be first. Since the y is first, though, that means that our hyperbola is going to be opening up and down. Okay, so your center is at 0, 0. So I'm going to go left and right by 2. Okay, that's up and down, just kidding. Up and down by 2. And I'm going to go left and right by 4. Okay, so I'm going to create this box shape. That highlighter doesn't show up well. And then I'm going to create my asymptotes that go through the center and the edges of the box that I just created. Okay. Since y squared is positive, I'm going to be opening up. So I'm going to start at my vertex here and create one that pulls towards my asymptotes, like that. Okay. So your foci, you use c squared equals a squared plus b squared. So your c squared is a, which is 4 plus 16, which is 20. The square root of 20 is 2 root 5. So 2 root 5 is 4.72. Okay. So this would be up and down 1, 2, 3, 4.72. So your foci would be located at 0 plus or minus 2 root 5. 1, 2, 3, 4.72. 1, 2, 3, 4.72. There's my other focus. Okay. So let's try the next one where it's not centered at 0, 0. Hold on, I'm going to let my dog out. Okay. I'm back. So the center is at -5, 7. You still take the opposite of inside both of them. Then your a value, or sorry, a squared is 32, which means that your a is root 32. 32 is 4 times 8, and this is 4 times 2, so it ends up as 4 root 2. Your b squared is 16, so your b is 4. Okay. So I start at -5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I'm going to go left and right by root 32, which is 4 root 2, and 4 root 2 is 5.65. So 1, 2, 3, 4, 5.65, 1, 2, 3, 4, 5.65, and then I'm going to go up and down by 4. So 1, 2, 3, 4, 1, 2, 3, 4. I'm going to create a box shape. Let's see how purple turns out. Purple, pink. That's a little bit better. Oh, my rectangle is kind of crappy. So we're going to go like this. Also, my dotted lines are not so dotted at the current moment. Okay, and then since x is first, that means, or x is positive, that means I'm going to take the hyperbola's opening towards the x-axis. So the focus, or the foci, to find the foci, you're going to do c squared is a squared plus b squared. So your a squared is 32, your b squared is 16, so your 32 plus your 16 gives you 48. So that gives you 12 times 4. This is 4 times 3, so I have 4 root 3. So your C is 4 root 3. So now, since this is not centered at 0, 0, and your foci are going to be left and right of the center, I'm going to take the x value of my center, which is -5, and I'm going to add and subtract 4 root 3, and then keep my y value, which is 7. So that's where your foci are located. Okay. Let's have you try the next one by yourself. See what you come up with. Okay. So moving on, we have the foci. You're trying to find the standard equation. This means that your C value is 6. Your vertices are a plus or minus 4. This should also clue you into the fact that it's a hyperbola, not a ellipse, because the foci are further out than the vertices are. So this means that your A value is 4. Notice that they're on the Y values. So that means that it's going to be opening up and down for your hyperbola. So that means that your y squared is first and your x squared is, or your y squared is positive. Okay, and your x squared is negative. Now, it's centered at 0, 0. Your x value is 0 because I have zeros in both the foci and the vertices. And then halfway in between plus or minus 6 is 0, and halfway in between plus or minus 4 is 0. So your center's at 0, 0. So I don't need to put anything in my parentheses. If I want to find my b squared value. Remember that c squared is a squared plus b squared. So I have 6 squared, no, that was c. Well, I guess we could do that. 6 squared equals 4 squared plus b squared. So I have 36 equals 16 plus b squared. So if I do 36 minus 16, we get 20, which equals b squared. So b is 2 root 5. So underneath your y value, that is your left and right, or sorry, your up and down by 4. So your a squared is 16, and your b squared is 20. And there's your equation. Okay, this one is similar. We're going to forego doing that one together as a class. This is very similar to what we did yesterday, except for that you have to pull out a negative. So let's try one example of that. So I have 9. We have to put the x's together and the y's together, and then put the number on the other side. So minus 16y squared minus 64y equals negative 116. So if I factor out my 9, I get x squared minus 4x plus blank, and then minus 16, and then y squared plus, make sure that you factor out your negative, turns it to plus. So 64 divided by 16 is 4y plus blank equals, I'm going to go to the next line, I don't know why I started so far right, negative 116 plus blank plus blank. So when I find my b divided by 2 term, I do negative 4 divided by 2 squared. So negative 2 squared is a 4. So I do 9 times 4 gives you 36. Then I'm going to do 4 divided by 2 squared is 2 squared, which is 4. So I do 16 times 4, which is 64. So then I have 9 times x minus 2 squared minus 16 times y plus 2 quantity squared equals negative 116 plus 36 plus 64, which gives you a negative 16. So now if I divide by a negative 16, notice that's going to change what is positive and negative. Did I pull something out right? 16 times 4 is 36. Oh, here it is. Negative 16 times by 4 is a negative 64. There we go. That's what my problem is. Sorry. It's super late. Not that that's a great excuse, but it does happen. Negative 116 plus 36 minus your 64 gives you negative 144. So I divide by negative 144 and negative 144. So then I'm going to move over here. I decided to start super far right on my paper. So I get 9 divided by 144 gives you 1/16. So I'm going to have x minus 2 squared over 16, and this one is negative, plus, because negative divided by your negative 144 is a positive, y plus 2 squared over 9 equals 1. Okay, so if you want to, you can write it as y plus 2 squared over 9 minus x minus 2 squared over 16 equals 1. So that's how you deal with the negatives. So make sure that you pull your negative out here, you change your sign here, make sure you multiply your negative 16 by this number to get a negative number. And then you may or may not have to divide by a negative depending on what you're given. Okay, let's look at the story problem. Okay, I lied. We are not doing the story problem. So you can skip the hyperbola story problems on your homework. Yay!